Hello everyone, how are you? Let's code again. Today we will solve the Leetcode problem number 4, which is median of two sorted array. It is of hard level problem. It's really not easy to be solved. We need to think how to solve it because it requires O of log m plus n time complexity. Okay, what's the issue here? What's the problem? We have given two arrays, nums1 and nums2, like this one could be this and this, and it's already sorted ascending in ascending order, and they want us to return the median of the two sorted array, and we should do it by time complexity O of log m plus n. Okay, so what's the median? Basically, if we have one array like this one, the median is the value at the middle of the array after it's sorted. So if we have like even number of array like this one, I think 1 2 3 4 5 6 7 8 9 10 12 element, so we pick the two middles, we add them together, and then we divide them by 2. In this example, it will be 5.5, the median of this array. But if we have an odd number, like here, for example, 11, we pick the middle one, which is this one. This is the middle, and this will be our median. It will be 6. So this is the median. Okay. We may think we can do this very easy by merging these two sorted array into one array and find the median. It will be very easy, right? Because merging two sorted array into one array, it will be time complexity big O of n. And finding the median of the sorted array, its time complexity is big O of 1. So it's fixed. It does not care about how big the array is. So the overall, it will be the time complexity big O of n. But that is not acceptable. We should do it big O of log n, or log m plus n. So how we can consider these two arrays to be similar to this one and find the median without merging them? Okay, let me explain again how to find the median. We need to divide the array into two parts, first half and second half. And if it's odd, it will be like this first half and the other half here, which will have here 11. Okay, so we have first half and second half. If we find any half, we can find the median. Simply for this example here, if we find this half, so we will find the last element here and first element here and add them together and divide them by 2. If it's odd number, so the first half, the next element, it will be the median. So now we have two scenarios, even number of array and odd number of array, and we can find the total number of element in our two array simply by sum the length of this one with the length of this one. Very easy. We can know if it's odd or even. This is one point how to solve our problem. Okay, so now we go back into this one. So we need to find the first half, like in this example, 6 element. So what we will do here, we will find the first half of this array, which is 1 2 3 4 5 6 7 8 9, which is 4 element, let's say this, and total length is 12, divided by 2 is 6, so total by 2 equals 6. So we say our window, if it's in one array, it will be 6. Our first half, it will be 6 elements. So we pick one of these two and find their half. And I started with the big one, but it's better to start with the small one. So first we need to do binary search on the smallest array, and I will explain why in the smallest array. And then we need to find these 6 elements, so which is half of all element, number of all element is 6. So we start here and we do binary search. and actually we will start from 0 plus the largest one divided by 2 and then minus 1 because it starts from index 0, so we will take this one. But half is all of them is 6, so this is only 1, so we will pick 5 elements from here. Okay, then are these 6 elements the same as these 6 elements? They are not. For first look, they are not. But how we can do this by programming? We can say, is this one less than or equal to this one? If this one is less than or equal to this one, then yeah, we picked the small one. This is good. This is good. But we come also here and say, is this one less or equal to this one? It's not. So this we should not pick it. This we should not pick it, and we should pick this one. So we need to do binary search again here, and half of them is also 1. So we will expand this window by 2, and we will decrease this window to become like this. Okay, so now it's 6 element again, but our window is different. Here is 2 element and here is 4 element. We come again, is 3 less or and equal from 7? If yes, let me delete this one. Actually I used white color, no problem. Okay, is 3 less than or equal to 7? Yes, this is good. So 3, yes, it should be in our window. But is 6 less than or equal to 5? No, it's not. So we should not pick 6 because 6 is not in our window, as you see. So we should pick 5. Okay, so we expand this one again using binary search. We expand it again. Okay, so here is 3 element, and here also will become 3 element. Okay, become 3 element here again, and we do our check again. Is 5 bigger or equal to 6? Smaller or equal to 6? Yes, 5 is smaller or equal to 6, so 5 is good. But here we have another problem. Is 4 smaller or equal to this element here? But we don't have element here. We don't have an element here. So this edge cases, we can solve it. How we solve it, I will explain to you. How we solve it, if we come to edge cases here, we assume we have positive infinity. And if we come to some edge cases here, we assume we have negative infinity. I will show it also in these 2 examples. Okay, but we may think from the beginning we can add another element here, plus infinity and minus infinity. We do the same here, minus infinity and plus infinity here. We can add it and minus infinity, and it will work. Yes, if we do this, it will work and it will give us a correct median. Why? Because we added 2 items to the right and 2 items to the left, so one of them cancel each other, and we protect ourselves from going too far to the right or too far to the left, because minus infinity is the smallest number and biggest infinity is the biggest number, and there is no number bigger than infinity, or no number is less than minus infinity. But if we append plus infinity, it's not a problem because it's big O of 1. While inserting minus infinity to the beginning, what will do, it will shift the rest element to the right, and this operation is big O of n, which is against our condition here. It should be big O of log n. So we cannot actually insert value minus infinity and plus infinity to our array, but we will simulate that we have negative infinity and plus infinity in the edge cases. We will simulate it anyway. So simply we do binary search on the smallest one, and I told you I will explain why we do binary search on the smallest one. For example, I'll give you an example why in the smallest one. So if we did binary search, here is 1, here we will need 5, because 6 minus 1 equal 5, and this is big array, we can have 5 elements. But if the case is reversed and we start from here, from up, and this is our middle window, our first half, 4 and 6 minus 4 is 2, so we need 2. But let's assume then we did another binary search here and become 2 elements here. That 6 minus 2 equal 4. And we don't have 4 elements here. And if it's become only, maybe there is one, some cases depends on our number. First half here it will be only 1 element, and here we need 5 elements, and this does not work. We can solve it by some if condition and some other operation, but it will be complicated code. So it's better we start with the smallest array and do our binary search. Also, doing binary search on the smallest array will be faster than doing binary search on big array, because this could be very big. We don't know how big it is, and this could be very small. So we start binary search on the small array, it will be faster. Okay, so I explained this point. Here there's another edge cases. We do binary search here, we take 9 and we say 9, and here it will be these 2 elements, and is 9 less than or equal to? It's not, so we will shift it to this point. And here is edge cases, so here we need minus infinity, okay, to solve our problem. And the same case here, we will shift to this point, so here we need plus infinity. If you run this code, you will see it come to these cases. So I think I explained theoretically how to solve this problem. Let's do it by coding. First, we have 2 arrays, nums1 and nums2. Let's call it A and B, and equal nums1 and nums2, because I want to find which one is smaller, which one is bigger. Okay, there is something why it come here. Shouldn't come, the indentation shouldn't come here. Let me try to delete everything and press enter. So A, B equal nums1, nums2. Okay, now good. If length of B is smaller than length of A, then we need to swap it. We say AB equal BA, simply. And then we need to find the total number of elements, which is simply length of A plus length of B. Okay, we need to find the half, so our left window, okay, half, which is simply total integer division by 2. And then here, as I explained, we have left and right. Where is the image? When we check like this element with this element, okay, or this element with this element, let's call this A and B. I will call this A right, and this A left, and this B right, and this one B left. Of course, the A and B, it will be shifted, but always the last element in our window, like here in our window, it will be right and left. I say different reverse order. This is left, this is right, and if this is our window, this will be left and this will be right. This will be A and this will be, and it will be shifted, and also the left and right will be shifted, but we call this B left and B right, and this A left and A right. So let's return to our coding. Okay, so A left, let's say equal A right and equal 0, and I will explain why, and B left equal B right and equal 1. Actually, we can put any number, 6, 3, I put 1, and here we can put any number, but we cannot put them both the same number. And this is just an initial value to make our while true from the start true. We make it true so it can run. This is initial value. We did not do any calculation yet, so I put any value, but we cannot put A left right and B left right all the same number, because it will make our while loop false and it will not do any code, it will not run any code, and it will quit assuming find a right answer. But first we will assume there is no answer, and then we will update a left a right to the correct value. So here we say while a left bigger than b right, or b left bigger than a right. So we need to fix something. That's mean when this is not smaller than this, okay, let me change color. When this is not smaller than this, when this is bigger than this, so we need to shift something. Or when this is bigger than this, then we need to shift something. There's something wrong and we need to fix it. When this is smaller than this and this is smaller than this, we met our condition and we create our window correctly and we can calculate the median. Okay. How to calculate the median here is, okay, after, let me clear. How to calculate our median here? Let's say this should be our window, okay? Let's assume this is our window, and just for example, and this is our window. This is wrong, but let's assume this is our window. If total number of elements is even, so we need to add two numbers and divide it by 2. But which two numbers we pick? We pick the biggest between this and this. Okay, let me correct it. Okay, this will be our window and this will be our window. So we pick the maximum between this and this, because this element here is the most right element of this window, and it's ascending from small number to big number, and this is our window. This is also same as this 6 element, same as this 6 element, but we know it's in order. So the maximum of these two number, it will be the most right number. So here it's 5. So we say 5 plus, here we pick the minimum of this number and this number. Okay, but here, as we said, we will assume it infinity. So the minimum will be 6. And as you see, the infinity protects us. So 5 plus 6 by 2, it will be 5.5. If number of element is odd, not even, let's say we have another number here, and let's say it's 11. So it's 11 here, okay, for example. So we have to pick this number. And as you see, this number is outside the window. So this is our window here, and this is our window here. This is 6 elements, so it's outside. Okay, outside, but we have a number here and we have another number here. Which one we pick? The outside, it will be the minimum of these two numbers. Because as you see, also it's ordered from small number to big number. So we pick the minimum between 6 and 11. The minimum will be our answer. This is how we solve the problem. Let's return back to the code. And here, while a left bigger than b right, or b left bigger than a right, there's something wrong. We need to fix it. So we start our binary search. We calculate the index, which is L plus R, integer division by 2, and then we calculate the index of the, this is the index for the A array. Let's say index of A list. And let's calculate the index of the B list, which is half minus I and minus 2. This minus 2 because index of B list. Because our list in Python starts from index 0, not from index 1. And this, from list to A, there's index 0, so it will be shifted by 1, and list B, index 0 shifted by another 1, so totally it will be shifted by 2, and this is why we need to remove 2 from the index. Okay, I get tired a little bit, I'm sorry. So okay, now we calculate everything. We calculate A left, After we found the index, we can find the a left, a right, b left, and b right. So a left, it will equal to a for I, its index, if I is bigger or equal to 0. So we did not reach to the edge. If I is at the edge less than 0, so we will consider the value is float minus infinity. And same for the b left, or sorry, a right, it will equal to a I plus 1, because it's the next element after ai, after a left plus 1 index, it will be a right. If I plus 1 less than length of a, if it's not on the right edge, if it's past the right edge, we will consider it float infinity. The same we will do to the b left and right. So simply I can just change the letters, because it's same equation, just same concept, just different variable names. So I can do like this. I hope I'm clear to you guys. If you have any question, please put a comment and I will be happy to answer it for you. Okay, now we calculated the a left, a right, b left, b right. We do our condition now. Is it a left, a right, b left, b right correct value? So if a left bigger than b right, which is not good, so we change the r index, the right index, and we say it equal to I minus 1. Else, this is equation of the binary search. Left index equal I plus 1. And after we update either R or L, we recalculate the I and J and recalculate everything. And it will keep this iteration till we did not meet these conditions, which when we did not meet these conditions, it means we created our correct window and we reached to a good point where we can find the median. So after we exit from while, we can find the median. But the median, it depends. Total number of elements in both A and B, are they odd or even? So if total mod 2, which means total mod 2 equal 1, that's here, that means it's odd. So we return minimum of A right and B right. Okay, if it's not, it's even, so we return the max of A left, B left, and plus the min of A right, B right, all divided by 2. So let's try now and run. There's error. Okay, L is not referenced. I think I forget to initialize L and R. So I need to initialize L, R, which will equal, of course, 0 and length of list A minus 1. Okay. Okay, so let's run it again. Yeah, it seems running correctly, but let's try and run it on the Leetcode. So I click submit here and let's hope it will be successful. Yeah, it's successful. And look at the runtime complexity, 100% better than others. But this could change. Like if I submit again, it will not be 100% better. Well, actually, it's again. Yeah, and memory usage also is good. So I think this is a good solution for this problem. I hope I was clear to you. Please write a comment, anything, and if you have any question, also write it in the comment and I will happily explain it to you. Thank you.